Hey everybody, welcome back to another video on Unit 3 and kind of a departure from what is normal for video lectures. I'm gonna try to make determining electron configurations a little easier using a funny way that I've kind of been showing students for a little while now. And this funny way has to do with an underground hotel. Okay, and so with the underground hotel, this thing here is the lobby. Okay. This is the funny lobby. And then there's floors underneath the ground. Okay, there's the first floor and the second floor and the third floor. And the important thing is the further down we go, the floors get numbered bigger. Okay, so it's 1, 2, 3, 4. It's not the other way. Okay, so here's what ends up happening because of the way the ground is at this thing. It turns out that the first floor, underneath the first subterranean floor, can only have a very limited number of rooms because otherwise the lobby is going to collapse in on itself, or collapse in on that. So in the first floor, we only have really one room. Okay, and that one room is what I'm going to call a simple room. Okay, and so in the first floor, we have a simple room. I have it kind of denoted as blue there. And so what ends up happening is we're in the lobby and a huge soccer team just came in and needs a space. But the soccer team has to abide by the rules of the hotel. The rules of the hotel, because the owners of the hotel want to make sure that the hotel stays clean and neat and they don't have to do anything. So the rules of the hotel is you have to stay close to the lobby. Okay, your rooms we're going to put you in rooms that are closest to the lobby first, above all else. And then we're also going to say that if there's rooms that are equally close to the lobby, we're going to keep you separated from each other. That way we're more likely to keep our rooms clean and neat. Okay, so the first floor, there's really only one room. Okay, and so the first two people get assigned to this room. And so I'm going to assign people. I'm going to use kind of it's funny, the simple room. I'm going to kind of use a simple stick figure, kind of a half of a stick figure here with a foot and an arm. Okay, and so one of them goes in there, in that room, and then the second soccer player comes in and says, I need a different room. And the hotel says, nope, you cannot be in a different room. And he says, well, because we're in the same room, I'm going to always face a different direction as this guy because it's kind of weird. So he's upside down. Okay, his hand is there. Okay, now that occupies all the rooms in the first floor. And it's double occupancy. So only two people can fit on the first floor. So now we're going to go to the second floor. So again, we're going deeper underground. And because it's deeper underground, yeah, we have a simple room in blue, but now, we have the party rooms. Okay? They're in yellow. But the rules say that the next teammates that come in, that get filled in that room, they have to be closer to the lobby. They have to be closer to the ground floor here, right? So that means that the next two teammates, one is going to go this way, and then one is going to go this way because, again, they're arguing about being in the same room when there's all these other rooms to use. And so now here's what we've done. We've put 4 people into the hotel, and we've put them in following the rules of the hotel, the room filling rules. Now, the party room, we still have a whole bunch more soccer players in. So here's the thing. The first and foremost rule is that all the guests have to stay as close to the lobby as possible. But the way the hotel is dug, the simple room on the second floor is just slightly above the party rooms. Okay, this was because of the way the ground is. It was easier to dig kind of on a slant. So here's what we're going to do. It's a party room, so I'm going to put one dude, one soccer player in the first party room. Okay, now the hotel lobby says, or the desk clerk says, well, if we're going to put another person in, if we're going to put the 6th person into a room, we don't want to put them in a party room together because then they'll start partying. So we're going to put them in separate rooms. So there's a party room here and a party room here. And so now we have 7 guests in the hotel, 7 soccer players, and they're all following the rules of the hotel. And remember, the most important rule of the hotel is to fill closest to the lobby first. They have to stick to stick as close to the lobby as possible so that the lobby can keep, so the front desk can keep an eye on their guests. Okay, so now there's 3 more people, but the primary rule says you have to fill the rooms that are closest to the lobby first, regardless if there's any more floors or whatever. Okay, so however much they don't want to, they're going to pair off. And again, because they're pairing off, they have the same problem as the group on the first floor. The pair on the first floor is they're gonna kind of spend time in opposite parts of the room. So we're gonna put one kind of up and one kind of down there. Okay. Now we're out of rooms on the second floor, and so now we're going to go down to the third floor. And the third floor, again, because it's deeper in the ground, we're able to have a bigger floor there. Okay. And so we have the simple room. We have a party room, but now we have these green rooms. These are called the dance rooms. Okay, so here's what ends up happening here. Okay, and this is where it gets kind of fun, is that now 2 more soccer players come in, and they're going to go into the simple room. And again, they have to be as close to the lobby as possible. Okay, and then we have the party room. So we're going to put people in the party room. Okay, and so far we have a team of 18 soccer players, okay, and they're all following all the rules really nicely. What floor is the dance room on? The dance rooms are on the 3rd floor, okay. They built kind of this weird thing. Here's kind of the exception that happens. This is really funny. The rule of the hotel says that you have to be closest to the lobby, okay. Well, which rooms are closest to the lobby? Let's see. If we look at where the bottom of the 4th floor simple room is, it's actually high. It's actually closer to the lobby than the dance rooms. So if we're going to put more people, if this soccer team is going to get bigger and bigger, okay, we're going to put people in the 4th floor in the simple room because it's closer to the lobby. Remember, that's the hotel's primary concern, is that it has to be close to the lobby. Regardless of what floor you're on, it has to be closest to the lobby. And because it's underground, the floors aren't built kind of straight across like they would be if they were above ground. And so that means now we fill the 4th floor simple room first. And then after that, we would go to the 3rd floor dance rooms. So if we had any more soccer players, they're going to fill here. And again, they're going to get grumpy if they're paired off. And so we're going to fill like this, and then we would pair them off if we need to. Now this soccer team only had 20 soccer players, I said, but it had 8 staff. So it had a coach and 2 assistant coaches and 5 trainers that came with them. Okay, so let's now take this and show how this is going to work if we have an electron, or if we have an atom. Okay, so here's the thing. These blue rooms, these are the S simple rooms. Those are the S orbitals. Okay, these are the P orbitals, and these are the D orbitals. So let's say we have an atom that has 17 electrons. Well, again, the rules of the hotel, the rules of filling say you want to stay as close to the lobby as possible. So we're going to do 1, 2, and this is where those special filling rules come in. if electrons are in the same room together, they don't want to spin in the same direction. Okay? And then, let's see. So there's 2. We put 2 in there, so that means we have 15 more to go. So now we go to the 2s, because we have to go closest to the lobby. And then once we have the 2s's, what's the next closest to the lobby? Regardless of what floor it's on, remember, regardless of what shell we're in, whether we're in the first shell, the second shell, or the third shell, okay, we want to go closest to the nucleus. The lobby is the nucleus, right? It's kind of neat. Okay, so now we're going to go here. We're going to go P. Oh, what did I do? I did that backwards, okay? Because what do we know? We know that electrons only don't want to pair unless they have to. So we actually have, let's see if I can get this right. So we have 1, 2, 1, 2. And so now we're going to go here, 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 17. So we have 2, 4, 7. Okay, then we're going to go there, there, there. That's 10. So so now we've followed all the rules. Okay, the electrons are closest to the nucleus. That's the lobby, nucleus. Okay, they only paired if they had to, and we filled each room, and they spinned opposite from each other. Okay, but now we have 10. We need to get to 17. So again, this is the S simple room. This is the party room. This is the dance room. I picked those because it's S, P, D. So on the third floor now, because that's the next closest to the nucleus, we're going to put 2 in there. And now we're at 12. We're going to go 13, 14, 15, 16, 17. So that tells us exactly where the electrons are. If you think of an atom as this hotel, what we want to do is to take where they are, and we want to write a electron configuration based on what we have. So we have first floor, S, so in the first floor we have the simple room, and how many electrons are in the simple room? 2. Okay, on the second floor we have an S orbital, so our simple room, how many electrons are in the simple room, or in the S? It's 2. But then we also have on the second floor the party rooms, which have 6, right? And now on the third floor we have 3s, 2, because again it's the simple room, and then we go to the party room, 3p, and then how many electrons are in the party room? Total of 5. And so the hotel never changes. The way the electrons fills in this, the first floor, second floor, third floor, the first energy level, second energy level, third energy level, it never changes. It always stays the same. What changes is the number of electrons. What if we had something with 4 more electrons? Well, okay, so now instead of having 17, now we're at 21. So we would go here. So now that's 18 electrons, 2, and 6. That's 2, 4, 10, 12, 6, 18. And now we need to put 3 more in. So we would go here, and then we would put 1 here in the dance room, however much we wouldn't want to, but that's what we do. Okay. And so now we would have 1s2, 2s2, 2p6, right? And then 3s2, 3p6. Let me just pick it up here. So it's 3p6, 4s2, because we fill the 4th floor, and then we're going to do 3d1. That's where that one is. That's on the 3rd, regardless of what we call it. So that shows us, using this underground hotel, shows us how we are going to fill electrons. So I hope this helps. I hope that clears it up, or at least makes it a little more understandable. And we'll spend some time in class dealing with electron configurations as well. There's some really neat connections that we can make to the periodic table. So have a great day.